Today's lesson is 11.4, multiplying and dividing using rational expressions. Now this is very similar to the simplifying rational expression, and you do need to watch that one first. However, if you thought that lesson was a little easier, this lesson is along the same lines. So to multiply a rational expression, reminder, rational means fraction, we cancel like multiplying fractions, right? Numerators of either part can cancel with denominators of either part. So for example, we've got x minus 9 over 4 times 5x plus 3, and we've got 8 times 5x minus 3 over x minus 9. So this, how we would simplify here would be, we would take ones that are the same. So let's look at the top first. So x minus 9, is there anything on the bottom that is exactly x minus 9? Found it right here. Those would completely cancel. Next, 8. Is there anything on the bottom that can cancel or partially cancel? Because 8 is not in a parentheses, so the ones that aren't in parentheses typically can have partial cancel. So like here, 4 and 8. 4 goes into 8 twice. So if we divide by 4, I'm going to get 1, and divide by 4 up here, I get 2. Since there's something left over, I'll write 2. Now, I don't need to write this one, but just to make the point, we'll write. Next, 5x minus 3, 5x plus 3. They have parts that are similar, but the different sign makes them different, so they just stay behind. And so my final answer is going to be 2 times 5x minus 3 all over 5x plus 3. Now, if we had, just an example, what if the 2 happened to be over here instead of over there, right? If the 8 had switched spots, the answer would still be the same. You just need to make sure that the top multiplies by whatever's on the top and the bottom multiplies by whatever's left over on the bottom. So we'll see that in a couple more problems, and I'll emphasize that. Next, you can also view the multiply symbol as basically extending the fraction of the second. So if you just ignored that this was a symbol in the first place and extended the line, that's basically what we're doing, treating like this as one big fraction over another big fraction. Okay. Next, simplify. We've got 2x minus 9 over 4 times x plus 3 times 9 times x plus 3 over 2x minus 9. So again, we're just going to deal with the top first this time. 2x minus 9, 2x minus 9. Exact match, they cancel. 9 and 4, they can't cancel, right? We got 2, 4 going to 4. 9 has 3 and 9, right? X plus 3, complete cancel. And all that's left over is 9 and 4. So our answer is 9 over 4. Next up, we have 3x plus 7 times quantity x squared plus 1 over 4 times quantity 3x plus 7 times x squared plus 1 over 2x. Now in this case, we've got 3x plus 7 cancels. Next, x squared plus 1, I don't have a match on bottom. Now you may have noticed, there's a match on top. These cannot cancel, right? Why does 3x plus 7 over 3x plus 7 cancel? As a little reminder, it's the same reason that 3 over 3 would cancel, right? 3 over 3, they both are the same, they'd cancel. Well, 3 over 3 equals 1. If we did 1 times this, that's the same thing as it already, right? 1 times x squared plus 1 is x squared plus 1. So those can't cancel, right? Though we can't cancel because these would be a number times itself again. It's getting larger, right? And then on the bottom, we've got 4 and 2x, also both on the bottom. They don't cancel. So our final answer is going to be these two things times each other, x squared plus 1, x squared plus 1. And we've got 4 and 2x on the bottom. Now we can multiply that bottom. 4 times 2 we can do. We're going to call that 8x on the bottom. You could also rewrite the top because they're both the same as x squared plus 1 squared. However, that is not mandatory. So this could have also been an answer, x squared plus 1 twice over 8x. Could have also been an answer. So I'm going to use my copy paste here. That over 8x could have also been an appropriate way to write the answer. I don't want you to think you have to do it this way. And this way, I would prefer 2 times 4. You could do that math. 2 times 4 is 8. So make sure you simplify where you can. We'll do a couple more multiply, and then I'll show you the little twist to division. Next, we've got 6x squared, x minus 7 over x minus 7 times x minus 1 over 2x times x plus 1. So perfect matches. Let's see, we got 6 and 2. These are the partial ones. They're outside. Divide by 2, I get 3. X squared x. Well, we've got 2 x's and 1, so 1 will cancel, and we'll still have 1x left over. Next, I'm going left to right on top, if you can't tell. X minus 7. We got a match here. Those cancel, and then x minus 1, x plus 1. This is left over, so I got x plus 1 on the bottom. On the top, I have 3 times x times x minus 1. So my numerator should be 3x times x minus 1. My denominator or bottom should be x plus 1. And there's my final answer. Next, we've got 3x plus 8, 2x minus 1. This one over here, I'm not going to read every single letter number. So we got 3x plus 8, 3x plus 8, cancel. 2x minus 1, still there. 2x plus 5, 2x plus 5, we got a match there. And a 4x. So I've got 2x minus 1, 4x. The ones that are basically clean of ink or pencil marks on your paper should be what's left over. Because there's only one thing left over on top, we didn't need to write the parentheses. If there was, say, a 5 left over as well, then I would have put parentheses and then the 5 would have been outside. Next one. Let's see what cancels here. 4. We've got 4 goes into 8 twice. So cancel. Divide by 4, I get a 2. X minus 3. There's our cancel there. And 2x plus 5. There's our cancel there. And what's left? These all canceled. So as a reminder, we have 1 left over. You don't need to write both, but as an example, 1 times 1 is 1. On the bottom, we've got x plus 2 and 2. Now, it doesn't have to be in this order, but I generally will write this as 2 times x plus 2 just because that's how I'm used to seeing it. It's not often. This is the way I prefer you not to write it. Don't write it this way. This just doesn't look quite right to me. X plus 2 times 2 like that. I almost feel like we didn't need another parentheses. But that's why I put the 2's in front. It looks like it's ready for distributing, kind of. So this is our final answer. 1 over 2 times x plus 2. Now, common mistakes here. Do not do this. Is to leave your answer in that form. I've seen many people who, the top went away. We just have 2 parentheses x minus 2. No, that's denominator, right? Numerator typically is how much we have left over. Denominator is the size of the pieces, right? Like 1/2. We'd have 1 piece left over, and the pieces were so big that 2 of them would make a whole piece, a whole pie, per se. So keep that in mind. So we still need the 1 there, because this is not the same as 2 times x plus 2. Next one, we're going to talk about division here. Now, division involves a little more writing, because all that's going to happen here is when you divide by fractions, right? As a reminder, how does dividing by, let's say, 2/3 look like? If I had a number divided by 2/3, what we would generally do is we would circle the division sign, because we're going to switch it to multiplication. And then that's going to be a flip, and when we also have to flip the position in our fraction. If we're flipping from divide to multiply, this becomes, instead of divide by 2/3, this becomes times 3 over 2, right? So the top numerator became the denominator, and the denominator, bottom, became the top numerator. That's the same thing we're doing here. The only difference is they don't look nice and neat like that. They're a little bit larger. So the first step of these problems is write it down in your on your work page if you're doing that, and then once we write it down, you're going to flip the sign. This is going to become a times, and x plus 3 is going to be on the bottom, and 2 times x plus 6 is going to be on top. So I did that ahead of time for us. 2x plus 6 flip to the top, and this x plus 3 up here flip to being down here, right? Let's see the flip. Okay, and now we're canceling. Now it's multiplying, and we're just doing what we've already done. X minus 4 cancels, x plus 3 cancels, and we're just left with the 2x plus 6. Since both bottoms canceled, we'll write that as a 1. 2 times x plus 6 over 1 is 2 divided by 1 is 2. So this is just 2 times x plus 6. Now some of you might be saying, wait, hold a second. The last problem you said we can't get rid of the 1. You cannot get rid of the 1 when it's in the numerator, right? If you have a 1 over 6, that's not 6, right? 1/6 is less than 1. In this case, we have 2 times a number over 1. Well, dividing by 1, they would just get the whole 2 times x plus 6. And that's why in the bottom, if there's a 1, it's just going to disappear. But in the top, it needs to stay put. Next one. First step, change it to multiplying. And it's not the piece before. It's always what's after the division sign. So generally speaking, I would circle this. And then the 2x plus 3 again is going to be on the bottom. And the 2x squared plus 1 is flipped to the top. Right? So these do the flip here. But when they rewrite it, like I have already, retyped it, we get right here. Now we're canceling. 6 divided by 3 is 2. Now, we haven't done this yet, but I see another number. 2 can cancel now, right? 3 goes into 6 2 times, but now 2 and 2, now this can cancel again. That can happen because 3 times 2 is 6, and that would completely cancel the 6 on top, right? But we did it one piece at a time, and that's how I would recommend doing it. Next, x plus 3 and x plus 3 cancels, and 2x squared plus 1 and 2x squared plus 1 cancels. Everything canceled, it's 0, right? Wrong. Remember, every cancel means we have a 1 left over. That's the other common mistake. Oh, everything cancels 0. I even had that in very high level classes where h over h equals 0. Not true. H over h is 1, just like 3 over 3 is 1. So how I wrote it is 1 over 1. Everything canceled. We had 1 on top, 1 on the bottom, and that is 1. We got about 4 more problems. So again, we've got the divide. So we circle the divide and flip positions with whatever comes after. So the numerator becomes the denominator, and the bottom becomes the top. Denominator becomes the numerator. And I rewrote it, and we've got 3x plus 1 on top, 3x plus 7 on bottom, and now we're canceling. 9x minus 7, any pieces that match on the bottom? Nope, staying. 2x plus 4, oh, right there, 2x plus 4. 3x plus 1, oh, that one too. And we're left with 9x minus 7 over 3x plus 7. They're just left over, and that's our final answer. Next, 4 times 7x plus 5 over 3 times 7x squared plus 5 divided by, oh, switch it right away to times, flip position. The whole top becomes the whole bottom, and the whole bottom becomes the whole top. And now doing that, we've got, see if we got it right, we've got 4 times 7x plus 5, 3, right? These didn't switch. Still in the same position. Great. Became times 27x minus 3 on top. Great. 10 over 7x plus 5 on bottom. Great. Now simplifying. We've got 4 and 10. 4 does not go into 10. Why did I cancel? They're both even. We can divide by 2. Divide by 2. Next, 7x plus 5. 7x squared plus 5. Squared is different. Doesn't cancel. This one will cancel over here. That one did not have the square. Next, 27. Does 5 go into 27? No, but 3 does. 3 goes into 27 9 times. So divide by 3, I get 9. And then x minus 3. I don't have anything else that can cancel. So we're going to get 2 times 9 times x minus 3 over 7x squared plus 5 times 5. And usually I'll rewrite that in a different order here. And because there was a little multiplying, I just rewrote everything that was the numerator, so the top pieces. Then I rewrote the bottom pieces. And then I'm going to do 2 times 9 is 18. And there's our final answer. 18x minus 3 over 5 times 7x squared plus 5. Last slide here. Try this on your own and check if your answers are correct. Feel free to pause the video to give yourself a 30 seconds or so to do that. And now that we're back, we've got, they flipped, they all canceled to get 1 over 1 is 0. All right, once they flipped, canceled, canceled, sorry, a little sloppy, so they're all 1s, and we get 1. Bottom, flipped, 12x squared minus 5, 2x plus 5, canceling. We're going to get, this cancels to give us 2, up, 2 over 2 also cancels, x squared minus 5 canceled, x plus 5 canceled, and it looks like everything canceled, so we're going to get 1 over 1 again, which is 1. Now, in a previous time, I had it cancel where 2 and 12 canceled, just to show you that 6 over 6 would still give you 1, but you can cancel that second time. You could have also had a 1 over 1. But this is why, even if you left it over, it would still cancel and simplify to get you 1.